Welcome everyone around the world, actually, which is nice to this webinar. Curiously important, aerosols. Remember when we first did in Spain, we did a video for schools about how to manage everything for the forthcoming pandemic. This was more than a year ago. We talked about aerosol plumes and putting lids on toilets and wearing masks, and people were all a little surprised by all that. But here we are now. We know what the primary source of transmission is, and more of it is aerosol lead than touch lead. But also, as many of you know, we've been doing a lot of research into CO2 and TVOCs and looking at the impact of those on children's learning, on their cognition. And it's been pretty scary, actually. I was only this week, I was in an institution for looked after children, and the levels of CO2 walking around, you could feel the difference walking into the rooms. We have our little monitors, but you could just feel the danger, actually, as you walk from room to room. So, this is timely, it's important. Ventilation matters. You're going to hear from a mixture of people talking about what we know now, and right through to Brendan really talking about how we're going to try and protect schools with geofencing to try and keep pollutants away from them. The school I was in this week, the TVOCs were incredibly high. They'd worked very hard on keeping all the surfaces clean, but the chemical damage from that was profound, and I think the surfaces were clean, but the children were brainwashed, So this is a complex area. Let me just say, if you're listening to all this, we have Diego, who is our wonderful interpreter and a good friend. Thank you, Diego, for being here. And if you're hoping to listen to this in Spanish or English, then on your screen you will see a translate button, and you have the ability to change to Spanish or English, nothing else. But if you're wanting to hear me at the moment speaking in Spanish, you just click that Spanish button and you will hear Diego translating what I'm saying as we go. And if somebody's speaking in Spanish, you click the English button if you want to hear the English, and it's still Diego, you'll hear him translating back the other way. So we're hoping that this will be fine for everybody. You don't have to be brilliant at English or Spanish. And we're also hoping that you'll be willing to chip in a few questions. So we have two ways that you can do that. There's a little button down there that says Q&A. If you want to just post a question in there, we will see it. The panel here will all see it. You can put it in English or in Spanish, and my colleague at UCJC, Farid, there will help me with the movement between Spanish and English in there. But also we have the chat window is open, and feel free to be in the chat window and just chat as we go. Really, we're monitoring all those channels. So if that sounds like chaos, I hope it isn't. And I hope actually that we can get started. That's all I really have to say at the beginning. We have a little roundup at the end, but I think we'll go straight away if Lise is ready with Ricardo, and he's got about 13 minutes to say to us via a video. And if you haven't Googled him, you probably should have done. He's senior, he's important, he's significant, and he plays a really key role in terms of policy across education. So let's hear from him. As he goes, feel free to ask your questions in the Q&A, post your comments in the chat, and to listen in English or Spanish, you make your choice. Please, let's go.
En primer lugar, tengo que dar las gracias por invitarme a este webinar de la Cátedra Felipe Segovia de la Universidad Camilo José Cela para hablar precisamente de algo que me interesa muchísimo y que creo que es de rabiosa actualidad, y que es hablar precisamente de esa visión general que tenemos sobre los espacios cerrados en centros educativos. Se trata de una cuestión muy seria desde que supimos, algunos ya lo habíamos avanzado al principio de la pandemia, que el virus se transmitía a través precisamente de los aerosoles que emitimos simplemente con nuestra respiración. Y claro, cuando estamos en un ambiente cerrado, pues esos aerosoles ocupan la totalidad del espacio y tienden a tener la misma concentración en todos los puntos de ese espacio. Y entonces, ¿esto realmente cómo influye dentro de las aulas y dentro de los espacios en general? Cuando uno habla de espacios educativos, siempre tiene en mente las aulas, pero veremos que cuando hablamos de espacios educativos tenemos que arrancar incluso de cuando salimos de casa para venir al colegio. Pero vamos a centrar primero el tiro en las aulas. Las aulas, en términos generales, son lugares con una morfología ya diseñada para que haya una buena iluminación y, por lo tanto, tienen siempre ventanas. Por lo tanto, es relativamente fácil realizar una ventilación cruzada de forma que tengamos al menos 6 renovaciones, 6, 7 renovaciones de aire, de todo el aire del aula por hora. Y eso es lo recomendable. Ahora bien, ¿cómo hacerlo? ¿Cómo estar seguros que estamos realizando las renovaciones bien? Y estas renovaciones realmente me van a permitir tener una temperatura adecuada para el trabajo sedentario que realizan tanto los docentes como los alumnos en las aulas. Pues como recomendación general, yo siempre digo que además de la ventilación cruzada tenemos que tener elementos de calefacción justamente enfrente de las ventanas. ¿Por qué? Porque eso va a ayudar a una convección forzada a elevar el aerosol hacia la parte superior y a que salga por la parte superior también de la ventana, alejando ese aerosol precisamente de la zona de respiración tanto de los niños, los alumnos, como de los profesores. Preferiblemente la calefacción se tiene que hacer desde las zonas más bajas. Lo suyo es tener convectores o radiadores que estén en las zonas bajas y enfrentadas sobre las ventanas. Insisto, ¿por qué? Porque lograremos que ascienda el aire caliente por convección natural hacia la parte superior y saldrá por su propia inercia de manera natural, manteniendo siempre de esa forma una temperatura, si no de confort, desde luego sí una temperatura adecuada para el trabajo. Y realmente, ¿cómo puedo estar seguro que lo estoy haciendo bien? ¿Cómo puedo estar seguro que estoy renovando realmente el aire? Bueno, pues lo podemos hacer por una medida indirecta de los aerosoles. Miren, cuando nosotros respiramos, emitimos CO2, que es un gas, y emitimos también aerosoles. Es algo proporcional. Emitimos tanto CO2 como aerosoles prácticamente de forma proporcional. De tal manera que si yo controlo la medida del CO2, podré tener una idea de cómo proporcionalmente están subiendo la concentración de aerosoles, que como sabéis es el vehículo que puede portar el COVID, que puede portar el virus, ¿verdad? Pues entonces tendré esa medida proporcional de aumento o de disminución de los aerosoles, simplemente fijándonos en el CO2. Pues bien, para tener una medida apropiada del CO2 tenemos que tener un aire con una cantidad de CO2 que no supere los 700 ppm, ¿vale? Y que sea lo más próxima posible al ambiente que tenemos en exteriores, que es el ambiente lógicamente menos favorable para ese contagio. ¿Y cuál es esa medida? Como os decía, el máximo serían 700 partes por millón de CO2, cuando fuera podemos tener entre 350 en ambiente rural y 400 ppm en ambiente urbano. Es muy importante, por lo tanto, tener sensores de CO2 en cada aula y que además los niños se acostumbren, los alumnos se acostumbren a estar pendientes de ese medidor para en el momento que supere los 700, tener siempre a los chicos alerta para abrir más las ventanas y que se produzca la renovación de aire mucho más rápidamente. En ese momento, lógicamente, bajará un poco la temperatura si fuera hace más frío, pero controlaremos perfectamente los niveles de CO2 y, por lo tanto, los de los aerosoles, reduciendo drásticamente el riesgo. Hay que decir que el CO2 se tiene que medir de forma continua, permanente en las aulas y teniendo un medidor en cada aula. No vale estimar, no vale entender que como en un aula tenemos tantas personas y el nivel de CO2 está en tal nivel, en este aula que más o menos tiene lo mismo, pues seguramente tendrá el mismo nivel. No vale estimar. Eso no es suficiente. Vamos, es que de hecho que estaríamos cometiendo errores seguro. ¿Por qué? Porque no es lo mismo cuando los niños vienen o cuando los alumnos vienen del recreo, que vienen a lo mejor fatigados, o que vienen de hacer ejercicio, o que acaban de comer, horas después de comer siempre tienes el metabolismo más acelerado y por lo tanto estás emitiendo mayor cantidad de CO2 y por lo tanto también mayor cantidad de aerosoles. Son muchas las circunstancias, son muchísimas las circunstancias que hacen que en un sitio o en otro tengamos distintos niveles de CO2. Ya no digamos del tamaño de las mismas personas que están en ese aula. No es lo mismo un muchacha de 15 años que un niño de 6 o 7. Evidentemente, evacúan de forma distinta tanto aerosoles como CO2. Por lo tanto, no me vale la medida estimativa. No son estimaciones, tiene que ser medida real. El medidor tiene que estar en un lugar muy de fácil acceso y muy visible para todo el mundo y un medidor por clase, fundamental. Imagínense ustedes que estuviésemos, por ejemplo, conduciendo un vehículo que no tuviera medida de velocidad y que tuviera que estimar la medida de mi velocidad en función de los vehículos que veo pasar. No tendría ningún sentido. Pues esto es lo mismo. No podemos hacer una estimación. Por lo tanto, la medida de CO2 es fundamental. Y fijaros que estábamos hablando de las aulas y de cómo se tiene que hacer dentro de las aulas. Bien, es que en un aula, dentro de lo que cabe, hemos dicho que es una situación que tiene fácil, entre comillas, fácil solución, ¿vale? Y digo entre comillas. Básicamente, ¿por qué? Porque todos los niños van a llevar, todos los alumnos van a llevar mascarilla y el profesor también va a llevar mascarilla. Pero es que solo habla una persona, que es el profesor, o cuando le toca a un alumno, hablar a un alumno. Pero hablan de uno en uno y nadie tiene que subir la voz, precisamente porque solo hablan de uno en uno. ¿Qué ocurre en los comedores? Tengo que hablar de los comedores porque es un espacio crítico y es un espacio en el que, no se ha tocado por ninguna de las autoridades, ni del Ministerio de Educación, ni de Sanidad, ni tampoco por las consejerías correspondientes de Educación o de Sanidad. Yo no he visto ningún documento que haga referencia a qué ocurre en los comedores. En los comedores de muchos colegios no se han tenido en cuenta cuestiones que sí se han tenido en cuenta en las aulas, como son la cuestión de la iluminación. Y hay muchos comedores que no tienen suficientes ventanas. Por lo tanto, no van a tener una ventilación cruzada correcta. Pero es más, en un comedor, ¿qué ocurre? Que todos los niños se quitan la mascarilla. Todos, porque tienen que comer. Y además, todos hablan, lo cual hay mayor cantidad de aerosoles. Pero es que además, como todos hablan, el nivel sonoro es muy alto. Por lo tanto, si te quieres entender con la persona que tienes a un lado, a otro o enfrente, elevas. Todo el mundo eleva la voz, por lo tanto, la proyección de aerosoles es mucho más alta. En resumen, ¿qué tenemos en un comedor? La tormenta perfecta para crear contagios. Por lo tanto, en un comedor, más que en ningún otro sitio, es absolutamente necesario tener medida de CO2 continua y, en caso de que la ventilación cruzada fuese insuficiente, hay que introducir otro tipo de sistemas, filtro SEPA o cualquier otro sistema de depuración del aire que me ayude precisamente a lograr una salubridad, una calidad de aire adecuada. Y hablemos también del transporte al colegio, lo que nos quedaba, ¿no? Porque claro, cuando hablamos del ambiente escolar tenemos que tener en cuenta que al igual que los trabajadores pueden tener lo que se dice accidentes in itinere, es decir, accidentes de camino al trabajo y ya se considera que es trabajo, pues en el caso de los colegios podemos considerar exactamente lo mismo. Yo recomendaría a todo el mundo que el transporte al colegio, a ser posible, se hiciera siempre o andando o en bicicleta, pero siempre a cielo descubierto. En caso de tener que utilizar el vehículo particular, nunca compartir el vehículo particular con personas que no son convivientes. Es decir, siempre la misma unidad familiar en el vehículo. De no ser así y de tener que compartir el vehículo, vamos a aplicar exactamente lo mismo que hemos aplicado en el aula. Es decir, calefacción elevada a alta temperatura y con el ventilador a tope y por los pies. Y llevar 4 o 5 dedos de todas las ventanillas bajadas. De esa manera voy a conseguir que el aire ascienda y salga por la parte de arriba, de forma continua. Veremos también que si controláramos el CO2 dentro del vehículo, a mayor velocidad del vehículo, mayor eficacia de esa ventilación y los niveles de CO2 se corresponden exactamente con los de fuera. Lo más importante dentro de un vehículo, lógicamente, no lo he dicho, pero es de cajón de madera de pino, es que si no estamos con personas convivientes, siempre con la mascarilla puesta. E insisto, calefacción por la parte de abajo, a tope, ventilación a tope y 4 o 5 dedos de ventanillas bajadas. Es la única manera que tendríamos de asegurarnos de que dentro de un vehículo los niveles de aerosoles permanecen correctos. Y para finalizar, si tenemos que utilizar transporte público. Bueno, aquí ya son parámetros que no van a depender tanto de nosotros, pero de forma general diría, si pueden, evítenlo, si no pueden evitarlo, procuren no estar en el mismo vagón o en la misma zona más de 15 minutos. Más de 15 minutos no es recomendable, sencillamente porque se considera que hay contagio seguro si estamos a menos de 1 metro de una persona sin mascarilla, aunque el transporte público llevamos mascarilla, ¿vale? Pero si estuviéramos delante de una persona sin mascarilla, incluso al aire libre, a 1 metro, insisto, sin mascarilla durante más de 15 minutos, se considera que el contagio es casi seguro. Este virus tiene unos niveles de contagio elevadísimos. Por lo tanto, mi recomendación en transporte público, por supuesto, siempre la mascarilla. Cuando vayamos a entrar o salir del transporte público, higiene de manos, fundamental, y procurar estar menos de 15 minutos en el mismo vagón, en el mismo autobús. Y por mi parte, nada más, creo que he ido muy rápido, no sé si he dejado las cosas más o menos claras, pero de cualquier forma estoy a vuestra disposición para cualquier cuestión que me queráis plantear. Muchas gracias.
Well, thank you for that. My goodness, Ricardo has started off with some fearful comments out of the description of the dining room as being perfect for contagion. I think is powerful and focused. Just to give you some sense, by the way, and we've been graphing the difference between classrooms with the windows open or the doors open. You can see here, I think, with no ventilation, within half an hour, the CO2 goes leaping way up. You'll see where the 700 parts per million line is. We've marked it at 1,000 here. But then when we open just the windows, the CO2, and for that matter, the aerosol droplets, because they're equally heavy, they come to the bottom of the room. You'll see that they rise very quickly because the windows only ventilate above the windowsill. They don't get that circulation of air. Is very interested in Ricardo's comments about putting the heaters below the windows to create circulation and designing rooms for proper circulation. And how do we make children aware of that circulation? We put on a saline, we have little bits of wool on the sail so you can see the flow around the room. We have some questions, and I have one from Raphael here. Thank you, Raphael, who's really just talking about relative and absolute measures and how both matter. And just going back to the diagram here, you can see the one line that is horizontal there is a room where the door and the windows are open, and we have a through draft sweeping through the room. So, knowing what the figures are out of doors, knowing what they are in the building, really, really important. Let's have, I think I've got another question here. Oh, yes, I have. So what are the recommendations? And I think for sure, we have to start re-engineering, thinking very hard about the architecture of our spaces, about the way we manage our vehicles. Just at the simplest level in Madrid, where the temperatures are going to be up in the 40 degrees, how do we maintain air conditioning and generous air circulation? My own car was built in 1931, and the windscreen opens. I can fold the windscreen open so that the air changes really rapidly. Maybe we have to go back to some of those early vehicle designs as we move to electric cars and find new ways to manage those. So I have a question from Maria about CO2, which, Fareed, I don't know if you can see that question. Help me with that, but Fareed, oh, you're muted, my friend.
Is there a suitable place in the classroom or dining room where to place the CO2 meter?
Yeah, it's a key question, really. Thank you, Maria, for that. In Belgium and in Ireland, they're putting a meter into every single classroom in every single school. I'm building a school. We're building a school together in Cork at the moment. So every single classroom. But then dining rooms as well. We've been alarmed by the level of noise in dining rooms, because that maps onto stress levels in children. They're very noisy places. But as Ricardo said, the noise translates into the children have to speak up to be heard, and that's droplet projection. And of course, the masks are off because they need to eat. So doubly dangerous. So I think for, listening to that first input, and we're going on in a moment to Yamo, I think, but listening to that first input, we're going to have to think hard about how we manage eating in schools. And I suspect it's going to be children with their lunch boxes sitting outside, or at best, and maybe at slightly less best, in their own classrooms. But the big industrial sized dining halls, I think, will go with the industrial toilets, because when you flush a toilet, the plume of aerosoles from the toilet goes about 4.5 meters, which is a vast distance. And so I think all those industrial scale components of the school are going to go. Yamo, you were going to say something. Chip in, and then we go into your video straight after.
Just a quick comment regarding where to put any measurement devices is that the first thing which we do is try to find out where and how the airflows are going in the room. So that's why you can then find those strategic points for the measurements. Don't put it where the air is still. Put it somewhere where you can see it. I think that is the only one. So you have to do your homework in the room.
Yeah, it's key, really, because we've certainly, I think we've measured something like 80-something, 83, 86, I can't remember now, examination rooms. And of course, we've found a huge difference across the room, in terms of the environment being optimal for cognitive performance, never mind health. Well, at least let's go to Yamo's. Oh, sorry, Philomena, please chip in here.
May I make a remark there? We have recently done some studies in classrooms, but also in a lab study, to figure out where to put the CO2 sensor in a classroom. And that depends very much on the ventilation regime that exists, as I said just now. We found out that in order not to disturb also the children, that it's best to put it on a wall in the opposite of the window. Somewhere in the breathing zone, so that means between 1.1 and 1.6 meter, and preferable in a natural ventilated room, also nearby the teacher on the wall, on the same height. We have seen, we want to advise that because we have seen major differences in CO2 concentration in the room. It could be at as much as 300 ppm difference between the worst and the lowest value that we measured in the room. So this could be advice.
Oh, that's very good. And Philomena, we found the same, particularly in those big exam rooms where you have 150, 200 children. The difference between the dark, badly ventilated corner with poor light and the good ventilated spot by the window. And we see that in exam performance, being somewhere between 3 and 5%, so just where you're sat in the room over and above the health, there's a cognitive and performance damage. And I think probably in the end, children will all need to carry their own devices, because the more we know about this, I mean, just very quickly, when we started looking 5 years ago, we thought ppm was...
Because when you breathe out, the concentration is super high. That's normal. And it's actually not the CO2 itself that is dangerous or health-threatening at all, unless it becomes so very high. But we will never see that in situations in classrooms or in living situations.
No.
So it's not advisable or recommendable to place the CO2 sensor nearby somebody breathing out, and then you will get 2,000, 3,000 ppm. That makes no sense. Yeah.
Our little sensors also measure light and other things. So like you, we aim for, a little bit above a meter and away from the window, and that seems to be a good compromise. Let's go to Jarmo, however, because in Finland, we have schools with air filtration devices in, and Jarmo's expertise and his professional knowledge is around filtration. So if we can't manage prevention, maybe we can manage filtration. And let's run that video, Lise, and then ask Jarmo some questions.
Thank you, Stephen, and really thank you very much for the opportunity to be involved in this event, and a hello to everybody there in Spain as well. So my name is Jarmo Kesanto, and don't worry, it's a Finnish name, so you won't remember it anyway. It's too complicated. But so originally from Finland, been in UK now for 25 years, and being involved in air quality, air purification technology for the last 15 years. So that's why, and now obviously the COVID problem has really boosted the people knowledge and worry about the air quality.
So, I mean, let's go straight to that air quality. I mean, and you've been working in air quality in the workplace, and that includes the learning environment too. Why does air quality matter?
Well, indoor air quality has been identified as one of the top 5 most urgent environmental risks to public health. And the building designs have been gearing towards energy efficient and all the good temperature, humidity, everything is the key point. But they have also then become more and more airtight bubbles. And that's why it quite often means that there is very little fresh air coming in, or the fresh air is coming through the different ventilation, air conditioning systems, which not necessarily means a good quality air. The workplace air quality should be a major concern to businesses, because that's really has an impact the health, comfort, and well-being and productivity of staff. And it means also that when we talk about the education premises, it's not only how do you feel like a bit dizzy or tired or because of whatever reason you think, but it's also then not giving you the best possible environment to absorb what's been told. So your learning limitations are also there because of the bad air quality. And you quite often can be mistaken for symptoms like other illnesses, allergies, stress, or colds and influenza. But people haven't been really connecting bad air quality to your not so very good feelings, and only then starting to think about it when you go out from your workplace or your university classroom, whatever, and you start feeling better right away. So I think that's the that's the point, that it's kind of an unknown, has been unknown thing for us.
Yeah, for many, I think, and although COVID has refocused us onto the aerosol plumes and so on, as you say, the component parts of bad air have been around for a long time. But perhaps, Yama, you could remind us what some of the causes of bad air are.
Yes, there are a few of them, and but one thing can be the building itself, and we are talking about sick building syndrome, which means that the bad air quality comes from the bad inside the walls or ceilings, water leakages, and then mold, fungus growing inside the building and spreading the particles. So that's the sick building syndrome, is quite often the hardest one to spot. And,
yeah, we had a school in Australia which they had a demountable classroom had been built over a historical refuse dump, and the pollution was coming up through the concrete floor into the classroom, and it was, in the end, it was too expensive to be able to repair. They just had to abandon the classroom. So that can be pretty serious, that cause.
It really is, and then if it gets really worse, it could be just that the only thing is just to demolish the whole building, because you can't fix it. Or like in countries like here in UK, when we have quite a lot of those grade 1, 2 listed buildings, even if you want to do something, you can't do anything. So then that's the main challenge. Then obviously you have the kind of a chemical pollutants which can be linked to the operations in the room. So whatever is happening there, you can release by accident, not knowing, different kind of things from the gases or liquids. Whatever your cleaning liquids are good for cleaning, but not so good to the air. And then also one thing, which is that I think you mentioned the concrete flooring, but the floorings quite often are also another source, because they are like in wet rooms and bathrooms where you have the linoleum coverings, which are not actually airtight or watertight, and they can release the glue which has been used up to the air. And then the overall carpeted buildings and rooms, the same thing, that they are releasing different particles. But then last but not unfortunately least is that we as human beings are probably one of the worst pollutants and carriers of the bacteria, viruses, and coughing, sneezing, even just simply singing. It means that you are spreading quite a lot of things, not to speak about the bit, let's say, not so pleasant things that your dandruff, your skin is releasing things which you don't really see, and that's, for instance, if you're allergic to dogs and cats, and that's not the hair, that is the dandruff from the skin, and that's in all over the place. Then unless you look after it, I haven't personal experience. I'm allergic to randomly to different dogs, which we don't know the reason. I can be in the room only 10-15 minutes in the wrong room, and my eyes are itching, and I start coughing and everything. So we are, the human beings and animals are the carriers and spreading it quite often as
and of course there's an equity issue there, because if you're a child who has a particular allergy to dust or to pollen, and on the day of an exam those counts are high, then you're going to get a worse mark than your classmate, and not because of your ability, but because of the environment.
Yeah.
I mean, Almo, I mean, you're here and we haven't really got to this point, because I don't know anybody who knows more about filtering these nasty things out of the air. So what have we got? What's in the armory? You know, how can we help?
Well, one thing is obviously the ventilation, so that you shouldn't be sitting in an airtight bubble or bottle there. So you should have a good ventilation, air coming in, air going out. That's one thing. But that ventilation is quite, and air conditioning included, cooling down or heating. So they are not necessarily at all keeping the air clean. So it means that you have to do something while the air is in the room. And that's something which I've been involved in the technology for the last 15 years. And it means that you can purify the air by taking it, like in our case, so we take the air in the room into our devices, and we purify it with electrostatic ionization technology, and then blow the clean air back to the room, even then through a carbon plate, which is then taking the smells, odors away from there, because that's probably one thing where you can spot the bad air is your nose. You can smell that this is not good, and it means that that would be irritating. And if you don't like garlic and you go to a good old garlic-based restaurant, so you can really. So we do that. And in our case also, that the whole building cannot necessarily be purified centrally. So you can do it in a room, and
just to clarify for people, I mean, you don't need a filter on every open window, because the electrostatic mechanism draws in the particles, and then they're filtered and other things. So you just need a scrubbing device in a room, and that does the job. And they're not huge, are they? It's not a...
No, it's not. It's about something like just over 1 meter roughly 1 meter high, and 35 by 35 centimeters the floor space, and just very light, 17 kilos, and plug and play. So you just roll it into the room, plug it into mains, turn it on, and it will clean the air to the level of required in operating theaters, in intensive care units, isolation rooms. So, but we can, and that's where the technology has been originally started from. So all the other premises have been coming during the last 5-7 years. So, which means that one thing is that this is not a COVID issue. The bad air quality has been before and will be whenever we get rid of COVID. It will be there. for various reasons. And it's not, although this is the hype and this is more serious than anything. But we had bird flu, we had pig flu, and we had all kinds of things early on, and they are bacteria, virus-based problems. So, and they will stay forever. So that's why the indoor air quality is important.
Well, listen, thanks. I mean, that's 10, 12 minutes, and we're coming to questions now. So I hope people have got questions. I mean, you and I have talked about this. We could probably talk for a fortnight, without repeating things. So, if people want more, there are links on the website back to yourself and back to the products that you're selling, which are, I always think, if they're good enough for the operating theatre, they're good enough for the primary classroom. So let's stop. Thank you for that, my wise friend, and let's go to questions straight away. Thank you.
Thank you, Stephen, and keep on breathing. That's helpful.
Thanks, Jan, and thanks, Lise, for queuing that up. So we've got all sorts of questions really to pose. I think for me, the big items in there were that insight that our classrooms have become more sealed, more closed down than the old Victorian buildings with their leaky windows and doors open and fresh air have given way. So even if we open the doors now, the doors only open into a corridor often. So that was a powerful insight, and the reminder that bad air preceded COVID. We had bad air problems before COVID. COVID has just been the crisis for all this. Jarmo, there's a complicated algorithm here. If every classroom had a filtering device in it, that would presumably bring the price of the things down incredibly low, the way that iPhones get cheaper when they make a lot of them. But then there'd be an energy price of them all running at the same time. So what would you anticipate 5 years from now? Do you think for sure every classroom is going to have some metering in it so that students are aware of the problems? Do you think 5 years from now they'll all have filters as well?
I would hope so, in a way or another, that it is going to be a long-term solution. Having standalone devices, whatever they would be, in each classroom would be probably the ideal thing, but it's a challenge. So I would say two things that we already discussed shortly about the dining rooms and the risks where the children, students, whoever are then eating without masks and shouting and keeping quite a lot of noise and being like a virus showers in that. So those premises I would prioritize right away, where you have more people. And the second thing in the classrooms is that I would challenge then the HVAC professionals to think more about not just the airflow, how many times an hour you replace the air, but what is the incoming air by quality and how to do that. So there are technologies, including our own, in where you can put that ventilation or ventilated air through a purification unit and blow it to the whole building. So, but yes, in a way or another, I can see that in the classrooms, in the communal areas like libraries and dining rooms, cafes, then would be then the point.
We have a question in from David, who's saying, and I hadn't thought about this at all actually, that elevators are a particular problem because people cramp into them, and he's suggesting they don't have great ventilation, and they're a particular problem. I know you've been doing a lot of work in the health service. Do the elevators, on the way to the operating theatre, do they have filtration?
We have one or two hospital locations. I think one of is a big research teaching hospital in Japan who has tested in all possible areas, including lifts. And then it means that obviously what can you put in a lift if it's a normal passenger lift with 6 to 8 people? There is the space of the device is one thing. But yes, they have been, and exactly what you referred, Stephen, is that those big lifts where you push the beds into the up and down operating theaters and the wards, and that would be then. So yes, because they are like a concentration of bad air. So yes, we can, and we are working at the moment in together with some our technology research partners also to solve the space issue, because I think those very combined closed premises are a big risk.
Yeah, thanks for that, and David, thanks for that question. Elevators were not on my horizon at all. I think top tip advice for everybody is keep out of the elevators, walk up, walk down. It's probably better for you anyway, but try not to get out of breath and pander as you do so. I know that Jarmo, you've put filtration devices into Finnish classrooms as part of formal research. And I know that a big issue that everybody's concerned about in education is just illness, really. We lose a lot of staff days, we lose a lot of children days. So in filtering the bad stuff, do we also filter out the low-level infections, the common cold? I mean, bluntly, when you put those filtering devices into classrooms, were teachers and children less sick?
Yes, that's really a proper detailed research studies, and one example that comparing the same classroom size, same age of children, same teaching methods, and the one which is cleaned compared to which is not cleaned by air means that there is something about 40% of the teaching staff, 60% of the children's sick days down. So it really is something, and a very recent one from here UK in a workplace is that since the devices have been into the office, there has been no single virus infection in the workforce. So it means that yes, it is, and the flu symptoms are obviously they are viruses as well. So yes, we have research studies showing that it can take everything, not those lethal COVID coronaviruses, but everything else inconvenient sources of infections.
Yeah, it'd be very interesting to model the cost of all that. I mean, a supply teacher to cover a sick colleague is, you're into hundreds of pounds, euros, and you wouldn't have many days covered to pay for the filtration for sure. So yeah, that's really interesting.
Yeah.
Look, we'll come back to some of this for sure in the roundup, but I want to move on to Philomena next over there in Delft. And Philomena, thank you, Philomena. She's where some of these videos we've just had a bit of a chat on Zoom. She's taken the trouble to produce something of the decent quality. So thank you for that, Philomena. Let's let's run that video and then let's ask some questions of Philomena.
Good day, my name is Philomena Bluijsen. In this lecture, I want to tell you something about airborne transmission of SARS-CoV-2 and ventilation measures to reduce this transmission. Before I do, I want to acknowledge a group of 36 colleagues from all over the world under the guidance of Professor Lydia Marlaska. Without this group, we would not have succeeded in convincing the World Health Organization that airborne transmission is an important route to consider and therefore important to account for in the fight against COVID-19, but also with other infectious respiratory diseases in the future. 1.5 years ago, at January 5th, 2020, WHO published the first disease outbreak news on the new virus. 3 months later, at April 4th, 1 million cases were reported. Last month, more than 180 million cases and 3.9 million deaths. So what do we know about this new virus? We know that respiratory infections are caused by pathogens exhaled through the nose or mouth of an infected person. The pathogen, the coronavirus in this case, is aerosolized from sites in the respiratory tract during breathing, speaking, singing, shouting, sneezing, and coughing, forming so-called respiratory droplets. The coronavirus is therefore not naked, but encapsulated in water-based particles containing water, salt, protein, and other components that are part of respiratory secretions and saliva. While these particles or respiratory droplets have a wide size range, most of them lie within the range from submicrometers to a few microns, the coronavirus itself has a size of around 120 nanometer or 0.12 micron in diameter. When exhaled, droplets can spread into the environment depending on the size. The blue particles shown in this figure are larger droplets that typically have a diameter larger than 100 microns, which fall to the floor under gravity within 2 meters of the source. The red particles are small droplets, also named aerosoles, typically smaller than 100 microns, which can stay suspended for longer time. How long and how far a droplet can stay or travel in the air depends on the droplet size and on the local airflow conditions like air velocity, temperature, and humidity. In still air, particles of different sizes have different settling times. Based on the Stokes law, calculations show that in still indoor air, exhaled particles of a diameter between 5 and 10 micron take 8 to 30 minutes to fall to the floor from a height of 1.5 meter under the influence of gravity, while particles with a diameter of around 50 micron would take about 20 seconds to settle from a height of 1.5 meter. So, in still air, droplets smaller than 10 micron can remain suspended in air for many minutes. But the air indoors is not still. The distance a droplet theoretically can travel is shown here for low indoor air velocities, 5 centimeters per second. As you can see, a particle of a size of 5 micron can in theory travel up to 100 meters with low air velocities, while a particle of 10 micron reaches circa 25 meters. With high indoor air velocities, 20 centimeters per second, these distances can be a factor 4 further. Another aspect that can affect the travel of a droplet is the humidity of the indoor environment in which the droplet is traveling. As soon as a droplet is expired, the water part will start evaporating. How much will evaporate depends on the relative humidity and the temperature of the indoor environment, as well as the chemical composition of the droplet. In this figure, an example is shown of a droplet with a size of 10 micron containing physiological levels of salt and protein, and its size after evaporation. It has shrunk to 40% of its original size. Now, what are the best environmental conditions for SARS-CoV-2 to stay alive? Recent studies show that SARS-CoV-2 survives the longest with low temperatures and extreme relative humidities, so both with low and high humidities. From these findings, it can be concluded that the usual recommended indoor climate condition a relative humidity between 40 and 60%, and a temperature of around 23 degrees Celsius, is not so bad to aim for. Now, SARS-CoV-2 can be transmitted through direct or close contact with an infected person, through indirect contact via deposited or transmitted infectious droplets via surfaces such as a ball here. These are also named fomites, or through so-called airborne transmission, in which virus-carrying droplets produced by coughing, sneezing, talking, and even breathing are transmitted via the air, including both large droplets and aerosols. So, when in close vicinity of an infectious person, this whole range has the potential to be transmitted, while when further away, the virus can be transmitted only by aerosols. This means that in theory, aerosols can be transmitted both by inhalation at short and long range. It is important to point out, however, that for each of the transmission routes, very little direct evidence exists. What we do know now is that the transmission via the so-called fomites do not or hardly occur, and that near the face of an infected person, the concentration of respiratory droplet is the highest. We also know from several outbreak studies that long or far-range airborne transmission can play an important role in cross-infections of SARS-CoV-2. So how can we reduce this transmission? We all know by now the well-known 1 to 2 meter to reduce direct transmission from mainly large infectious droplets. For indirect transmission, although we know that this virus doesn't play a role, cleaning surfaces and washing hands. For people who need to or tend to come close to possible infected persons, personal protective equipment can be used, such as facial masks and protective gloves. And finally, although it's still not publicly recommended by all nations, the use of proper ventilation measures to decrease the risk of airborne transmission. Proper ventilation means, first of all, to provide sufficient and effective ventilation. Ventilation that ensures the supply of clean air and exhaust polluted infected air from the breathing zones of each individual person, preferable without passing through the breathing zones of other persons and without recirculation of air. If general ventilation seems not enough, or recirculation, reuse of air cannot be avoided, add air cleaning devices. Ventilation can be established by just opening a window, natural ventilation, or can be established by using a mechanical ventilation system varying from only exhaust to very advanced air conditioning systems that supply and exhaust the air. Mechanical ventilation gives the possibility to control the amount of air that is supplied, exhausted, and/or reused. While natural ventilation, such as opening a window, is an uncontrolled form and therefore a less reliable way. Anyway, it is clear that ventilation will reduce the concentration of possible infectious aerosols. How those infectious droplets and aerosols will distribute and possibly along the way meet healthy persons is difficult to predict with ventilation at room level. If one wants to reduce the risk of transmission to nearly zero, source control should be used. That is, remove the possible infectious aerosols as close as possible to the source. Personal ventilation is an option here, but the direction of flows needs to be studied, since most available personal systems are supply air only. Then air cleaning. Since the start of the pandemic, different filter or air cleaning systems, permanent or mobile, are offered as an additional measure. Think of filtering of particles, such as HEPA filters, or cleaning with UVC, the ultraviolet part of the UVC spectrum that inactivates bacteria and viruses. Most UVC systems make use of UVC with a wavelength of 254 nanometer, which is harmful to skin and eyes and can therefore not be used nearby people. UVC with a wavelength of 222 nanometers, on the other hand, is not harmful to people and has shown to be able to inactivate, for example, SARS and MERS. But as far as I know, no system exists yet with this wavelength. Another point of attention is the fact that UVC cleaning only inactivates what is seen by the apparatus. Now, to test whether a mobile HEPA filter system can be used, for example, in a classroom as an additional measure, we have studied the cleaning effect as well as the effect on sound and draft caused by a mobile HEPA filter system for different settings and precisions. From these tests, we concluded that a mobile HEPA filter system seems a good additional measure on top of natural ventilation. But it should be said that the mobile system can result in unacceptable noise levels and draft effects, and that its cleaning performance depends on the setting and on the position in the room. So how much should I ventilate? This is not an easy question to answer. Current guidelines for air quality indoors are based on the CO2 concentration in air that is allowed. CO2 is used as an indicator of the presence of people. With every breath we take, we exhale CO2. With the equation shown here, it is possible to calculate the required ventilation rate per person in a space to keep below the allowed CO2 concentration. The air distribution effectiveness in that equation tells us something about how effective the air is distributed. For complete mixing, this value is 1. When we use natural ventilation, opening windows, single-sided or two-sided, this effectiveness can vary depending upon the temperature differences, wind direction, and dimensions of the space. In conclusion, assuming airborne transmission of SARS-CoV-2 is a route of transmission that seriously needs to be considered, it is clear that the question is not only which ventilation rates are required to protect against infection transmission, but also how one should ventilate for a certain situation. It is important now to rethink ventilation, specifically for indoor spaces with a high density of people during a long period of shared time, such as educational settings, offices, theaters, and gyms. It is clear that natural ventilation, such as opening a window, is not a universally suitable way of ventilating such spaces at all times. The new generation of ventilation systems should not just focus on the ventilation of a space, but provide a range of ventilation options that fulfill the demands of the occupants over time, whether related to health or comfort. Flexibility is therefore the key. Thank you for listening.
That's really useful and some great data. I was just reflecting as you were giving us that super exposition that we've been looking at the impact of environments on cognitive processes rather than health really over time. But the figures are all very similar. I mean, the figures you give for minimizing the coronavirus virus transmission 23 degrees, and we're saying, the cognitive processes optimize at 20 to 21 degrees, very close, and the humidity 40 to 60. That's exactly the figure we give for your brain being at its best as well. So it's not hard, all this. It's not as though over here we have the settings for healthy environments, and over here the settings for environments that are good for your brain. They turn out to be very much the same settings, although your caveat or thought about noise is a really important one, because we found not just decibel, but also noise rhythms can be very distracting. A lot of work in the motor vehicle industry on the impact of noise rhythms distracting you. They work hard to make tire noise quiet because it can be such a distraction that people crash. So, I think your concluding remarks there, which is, this is complicated, and we need agility, really. We need some resilience in our systems, but we need to be able to, there is no simple one-size-fits-all at all times in all places. But I think people listening to this are modeling already the suite, the portfolio of things that are going to make our classrooms, our learning spaces better. And so my question to you really about all this is really, and I might even ask this of everybody at the end, but why is it that our politicians don't seem to listen? I mean, I don't mean that in a political or unkind way, but everything that's been said so far this morning is reasonably unequivocal. The data is not easy to argue with. We're sitting on 5 million hours of data. You similar. Why do our politicians struggle simply to say, here's what we need to do to make learning spaces better? What's been your experience down there in Delft?
In the Netherlands, you mean?
Yeah, well, yeah.
We have had a hard fight with our government, and we are still in the middle of it. Actually, I'm a member of a committee that is trying to figure out why our government has responded as it has responded the last year, and is still ignoring most of it. While other governments, like in Germany or in Belgium, are listening. And so in Belgium, they are really taking care of ventilation at schools. They are using CO2 sensors now to at least get a reasonable ventilation rate. In Germany, they have been doing this right from the start almost. Merkel has already in October announced that ventilation is important. Now, finally, after more than a year, also WHO is convinced that airborne transmission is definitely an important route to account for. The CDC in the States is even convinced it's the most important route that we should account for. And what I said also in this video, the route by services plays an insignificant role. And we know that now. So washing hands until they are, how do you call that in English? That you have no more skin.
It's exactly raw.
Raw. That's the message we got all the time from our prime minister. Has made no sense at all. Even the 1.5 meters in places where there are lots of people makes no sense. And so you can just as well stay together.
You could hear the gasp, I think, virtually from the room when you put up that diagram showing droplet transmission, over 100 up to 100 meters, and then very easily achieving 10 to 50 meters. Well, these are significant distances, and
we found out that the major reason for this is that the team that is responsible in the Netherlands we call it the outbreak team management, that they are comprising mainly of medical people. And medical people have been educated that transmission via the air can only exist with droplets smaller than 5 micron. All other droplets, they claim, fall down within the 1.5 meter. So, now this is something we already from the start said that's nonsense. Physically, you can already, in theory, show that this is not the case. A second point that they really put as a criteria is the so-called R factor. They claimed if the R factor is around 1 or even below 4, it cannot be airborne. Well, this is also nonsense. And so there are many beliefs. They were so traditional. Now, hopefully, after this pandemic, they finally accept that we need to follow other criteria, other rules in this matter, and we're still fighting for it.
Yeah, well, let's hope for progress, and maybe as we nudge towards the future, it's appropriate to come to Brendan in particular, because he's been looking, of course, at those particles that are, PM 2.5s, the soot-based particles from diesel, and we know from a huge study in China that, I think it's over about a 9-year period, that children near to roads where the pollution had a high level of the PM 2.5 dropped up to a year of schooling on average. Yeah. They dropped a year of schooling before they even got to 15, So in a way, those soot pollutions even more damaging in terms of lost learning than COVID has been. So please, let's play Brendan's video next, and then
I can.
I see several hands up, but
yeah, I can.
I can, but we'll come to all that at the end, because.
Okay. Are you sure? Yarmo has had his hand up for a little while.
I know. I've watched, but we'll come to the end. Let's go to Brendan, and then we'll have a chance to chat together at the end, which is good. But I don't want to overrun.
We are a electronics and software company based in the north of England, and we specialise in vehicle electronics with a particular bent towards vehicle telematics, mainly for emissions-related functions. One thing we have been involved with in the recent years is projects with Ford, mainly to do with battery management systems. And our latest product is a low emissions geofence zone module. Now, to explain what a geofence is, it's basically a virtual fence that you can create anywhere in the world. This allows you to geofence areas such as the London low emission zone or the Madrid low emission zone, wherever it is in the world. And our vehicle can pick up that data using GPS. And when you drive into those zones, then you can do various functions with the vehicle. Now, the project we did with Ford is taking the PHEV vehicle, which is a petrol and battery-based system, hybrid. When you drive into that zone, as you get to that point of entering the low emission zone, we then switch the engine off and run purely on electric. You can then drive through London with enough energy in the battery, hopefully, and it will stay in that zone, stay in that mode until you exit the zone at the other side. If in the meantime the vehicle runs out of battery, it'll automatically revert to the petrol engine, but we block the user from doing that themselves manually. So the only way to do that is if the engine management system requires the engine. So it means that in those zones, you can basically only use zero emissions. Future-wise, we're looking at extending this from not just the mandatory zones around Europe and the rest of the world, but also you can add your own individual geofence zones via our web interface. So for instance, if you're very conscious of going through a small village or a low emission zone, you feel should be a low emission zone, you can add that yourself to the system. The next time you drive through that point, it will then remove the engine power and run on battery alone in that location. One example that we've looked at, and we've also spoken to another company based in the US, was to geofence every zone in their state, or in this case, in the country. That means that when you drive towards that school, you get to within whatever specification distance you want of that school, 100 meters, half a mile, whatever. It will then automatically again switch over to a geofence zone and go on to zero emissions. Again, when you pass the school and outside of the zone, it will then put the engine back on as required. We believe that this will be really beneficial to the schools, in that any vehicle going past has the ability to turn the engine off, should well do so.
Yeah. All right. Cool. Okay. So I'm Brendan Shaw. I work for Azura, and I've been involved in the connectivity and the mobile app side of the project. So as Neil explained, it's been a very interesting project. One of the market leaders to work with a tier one automotive supplier, especially in the commercial vehicle sector. And I think every day we sort of see this news about pollution and everything that's been done to reduce pollution in a city. So yeah, it's quite a remarkable project to work on. It's been a really exciting acceleration in all these different low emission zones that we're seeing start. So our product now being used across Europe on these commercial vehicles. So interesting times. And as Neil said, at the moment, it does allow customers to go there and set up their own custom geofence zones. But where we sort of see this project going in the future is more dynamic, so where we can monitor pollution levels in real time, we can then change vehicle dynamics, vehicle routing, the powertrain of vehicles in real time. So if we see a particular hotspot around a school or hospital or a key point on the route, we can automatically redirect the vehicle away from that pollution, or we can say, as Neil says, we can automatically switch the vehicle from this conventional engine, this petrol diesel mode, into electric mode, so we can save and reduce the pollution in those particular hotspots. So Neil, where do you think this is going to go in the future? What else do you think it's going to achieve?
That's a good question. I don't know.
Right?
No, the honest answer is
no. So in the sense of in the world, we're going to have more connected vehicles. Yeah. So we're going to have more connectivity on vehicles, more vehicles talking to each other, and more interaction between vehicles.
We're hoping that in the future we'll get more access to more controls of the vehicle. So for instance, if you've got vehicles that are non-hybrid, we want to have the ability to interact with the vehicle engine, because there are ways of reducing the emissions of vehicle engines by adjusting the calibration values in the engine ECU. Now, at the moment, these are fixed based upon the average use of the vehicle and what that vehicle type is. So for instance, with a transit van or truck, they're designed to maximize the torque, maximize their ability to tow heavy loads. That isn't always required. If you've got no load in the vehicle and you're driving on a flat road, you don't need the huge amount of torque that you actually would require towing a massive load. So we are looking at, and I have actually spoken to a particular customer in the UK about the ability to adjust the torque settings on the engine on a dynamic basis, so that when you're in a low emission zone, even though you have to run on fuel, you'll run on less fuel in them areas. Obviously, that's something for the future. At the moment, the ability to do this isn't available, but there are certain facilities going to be available in the future that should allow us to give us that ability.
Thanks for that. So I think one of the other interesting areas of growth is going to be last mile delivery, especially as we sort of come out of this post-pandemic world, where everyone's now going to be working from home and being at home more. We're going to see this last mile delivery increase. So I think the latest statistics from the US is going to be 2.1 billion home deliveries in the US this year alone. So 30% increase on last year. So we're just going to see that last mile delivery increase, in which case is going to cause more pollution. So hopefully, our system will come in place and it allow us to be able to reduce those pollution levels. And then, as Neil says, taking this further forward, and we can do this dynamic monitoring in real time. Then we have the ability, really powerful ability, to talk to vehicles and control where they are. What is their powertrain, right? However it works inside the vehicle, still a bit of a black art inside the vehicle, but being able to manage that, in real time, which will have a big impact, and it will reduce pollution in these inner cities where we are seeing this increased problems within pollution. And as we know, and as we're sort of seeing pretty much on a daily basis now, where these across Europe, any city above 50,000 people will be having zero emission zones. So this is now increasing across the whole of Europe, but pollution does affect the whole world at the moment. So it's quite interesting technologies, and I think one of the great things from this and been working on the project is actually taking these off-the-shelf products that we're using and actually starting to put them together so they all starting to talk to each other. And obviously we're going to see more of that in this connective world.
Thank you very much for that, and thank Neil for us as well when you see it next. Brendan, by the way, has been our great partner and colleague in developing our little Internet of Things boxes, our little thermometers that really do measure a lot of this stuff. Brendan, it just occurs to me that the market for this is companies thinking that looking after our health is to their commercial advantage, and Ford's huge manufacturer working with you to make their vehicles come between the driver and his intention or her intention and reduce the torque, the fuel consumption, the ability to. That's hugely exciting. But on the other hand, as we were just saying with Philomena, here's our government struggling to see the value in our children. It's a contrast, isn't it? With the huge growth in home deliveries and the need then to have vehicles that are family friendly, for want of a better description, do you think, and you've been doing a lot of work on classroom analysis as well, that's not what you're talking about here, but do you think as children start to work from home rather than from school, the home's going to look to be a safer, cleaner place for many of them than those urban, large industrial scale schools? What do you think?
Oh, very good question, Stephen. So obviously, first thing, thank you for allowing us the opportunity today to come and talk to us today about our products and what we've done in the past, and what some absolute great speakers. I've learned so much today, so some fantastic speakers. So, and also apologies from Neil for not making today's conference. So, I think, I think the first thing is I was looking yesterday on Twitter, and there was an article about how in London there was a traffic vehicle set up to monitor taxation on cars right outside the school, its engine running 24/7. So you are definitely right, Stephen. We don't have it very well at the moment. It doesn't take a politician to tell you don't put a car running with its engine 24/7 outside of school. So, and yeah, there's a lot going on. I mean, obviously, we are seeing this big drive in from many different areas, from increasing electric vehicles. Vehicles emissions are starting to get lower. From the pandemic, we are now starting to see this different working pattern. Homeschooling is probably a whole new conversation outside of this. But yeah, we are seeing, maybe more education in schools. But from a political point of view, across Europe now, we are seeing these low emission zones set up, at quite a fast pace. And I think last year there's about 200. This year there's over 500. And countries like Germany and Spain at the moment are really accelerating these clear air zones, mittling moment around big cities, which they probably see as a quick solution to try and reduce the pollution in these over polluted zones. But obviously around that is, how then do you still go and deliver your goods, and how do you still get to work, and how do you still get your children to school, all the rest of it. So it's a complicated problem. But I think what we're seeing is we are seeing the ability for technology, which is accelerating faster than anyone could predict at the moment. IoT devices is now like 10 billion devices online, and not just going logically, but going up at such a fast rate. So we do have this ability pretty much off the shelf now, to be able to link pollution sensors to to cars, to your mobile devices. And I feel the work that we've done with with Stephen, with Learnometer, is we should all be thinking about pollution like the temperature. If you're up in the morning, you get your news and your temperature's on your phone, and we should be thinking the same with pollution. And am I going to take a coat today, or what's my pollution levels going to be? So we should be seeing pollution the same as monitoring and looking at temperature. And I think some of the great speakers that have happened about pollution and how we can try to just avoid that pollution around schools or homes. So coming to your question, Stephen, I think we've seen these in-city pollution spikes go up really high. I'd love to do a study about how much extra pollution is now caused by home delivery. So they say people aren't going to work now, which is really great. But if you go to a big city, how many Amazon vans do you see driving around now delivering these goods? So if it be people now studying at school or home at university, are we just actually moving that problem from one place to somewhere else? And there's been some great studies around, recently with these, these pollution levels and, what's trying to achieve, how to reduce it. And I don't think it's going to be easy to move the school away from the roads or the roads away from the schools. But, we now have this off-the-shelf technology with, monitoring equipment, connected vehicles, mobile devices, real-time communication. So I'm hoping, I really hope that what we'll see, as of now, this more connectivity of the world and more awareness of air pollution and what it's doing to affect students either at home or at school.
Thank you for that. And I'm really going to come to Jarmo and Philomena as we wind up what's been a fascinating session. And, there are teachers watching this, probably some children, researchers, policymakers, because I'll make a point of putting it in front of them. Clearly something has to move. And, what could move is our awareness. What could move is the location. Retail has moved from, a lot of people driving their cars to a shop, filling it up with potatoes and driving home, to one van driving around distributing the potatoes. And we've certainly seen those changes, and we've seen the roads change. We've seen the airlines, the airports change. So something's going to change. And I'm just going to ask Jarmo, first of all, what do you think is going to change going forward? Will we just have learning from home, learning in the community, lower scale? Will we have cleaner, better schools, better equipped with technology, with better awareness? What do you think is going to happen? Just dream a little of 2030 and what you think it might be.
Thank you, Stephen. So I would say that the homeschooling, which has been the kind of a controversial thing during this pandemic, but I'm not quite sure if that would be any kind of a long-term solution, but at least only in the. So I think children will go back to the classrooms. You might have different, slightly different ways of doing it, but still, I think the main point is the school and classroom. And then that was my first raised hand comment is that first of all, thank you, Philomena. That was really good, good, detailed and fact-based presentation. One thing from that is just that whatever you select as your ventilation or purification system solution, don't forget that they all have to be maintained. And I've seen so many so-called ventilation systems which have never ever been cleaned, which are more dangerous when you blow air through them. And the same with the filters, including especially HEPA filters. If you don't change them, replace them, they are just simply more dangerous than useful. So the maintaining, like our own devices, they need an annual maintenance to keep them up and running in there. And then secondly, thank you also, Brendan, for that one. I just couldn't avoid of making a note that the diesel engines had been those criminals in the last couple of years. They've now disappeared from the headlines, so not anymore maybe so criminal. But one thing is the NO2 emissions. And I think that's something that diesel, yes, it's NO2, but also then that when we drive on the road, the tires and the road surface, you release NO2. Brake pads are quite a remarkable source of NO2. So whether it's a Tesla or anything else, totally zero emission, driving around means that you still emission. So there is no the clean truth and the whole truth anyway. But thank you.
Thank you for that. Thank you for that reminder. And Philomena, 2030, where do you think it's going to be?
You're still referring to the question about where we are going to work and educate? Okay.
Yeah, what's it going to look like? I
can tell you we did 3 years ago, we did a study with children, primary school children, in our labs, and we asked them actually the question, what do you want to change in your educational environment? And we meant to have them answer the question about indoor environmental quality, but they came with all kinds of solutions. And one of the solutions was to sit at home with their own laptop and to have a robot teacher in the classroom giving lessons. Now, I'm very curious about asking them the same question now, after having been at home for 1 year, if they would give the same answer. I know for a fact, I have a son of 17 years old who has been staying home for a long time. He was dying to get to school. He didn't want to have lessons at home anymore. They got bored. They got no meaning of life. They really got depressed. So if you would answer this in 1 year from now, when hopefully everything is back to normal, I would be able to give you a better answer. But my expectation is that we will get a hybrid form, more. We cannot go back to these full classrooms with 30 kids in the classroom, but we can also not go back by just teaching them at home, from home. That's impossible.
Philomena, thank you for that. And just a final observation from me, really, although there was so much there to digest and so much good input, which I'll thank you for in a moment. But Lisa and I were talking to a group of children in Scotland about halfway through the lockdown, and we asked them, a lot of them, we asked them to put their hands up and say, well, that's how many days a week you used to attend school. How many days do you think you need to attend to still, feel what one of the gang, still have classmates, best friends, girlfriends, boyfriends, whatever, how many days, and the average number of fingers that went up to 2.
Okay.
So, and that was, nobody said 5.
No.
So I think you're absolutely spot on with that hybrid model and how that staggers, and whether it's 2 days a week or, 8 days across the month. I don't know, but I think the greater awareness of making the place good for your health and good for your brain leads us to a whole lot of new choices. And I hope people watching this now and in the streamed version later will go away and think hard about all this. And I think what happens next is going to be very interesting. It's a fork in the road, and I don't believe the genie's going back in the bottle. And so much of the science you've shared with us and the work you're doing, I think, says things are going to be different, and that's going to be very exciting. Look, I'd like to thank, we're bang on time. I'd like to thank all of you for your inputs. They've been terrific. And what people listening don't know is we've had to chat a lot about this and prepare the comments and reflect on what we're saying. So, you've seen a useful contribution, but I've seen a contribution for some weeks before all this, and thank you for all of that time. I particularly want to thank Diego, who's out there. Now, he won't know how to translate this because he's too modest, but he's done an astonishing job through this of keeping everybody on track with whatever language they wanted to be in. I want to thank him, but he didn't just do that. He was part of our little development team working out how to do multiple channels and make the translation work for everybody. And, he's been very much a researcher helping to shape all this. So huge thanks to him. I will thank always Lise. I couldn't do any of this without her. She's been the supremo, has held all this together, done so much work, communicated with everybody, given me the timesheet to tell me when to move on. I mean, all the slickness of all this is down to her as ever. We've worked together for 30 years, which is a fabulous time, and I haven't regretted a second of it. So, Lise, thank you for all that work. And finally, my good colleague in Spain, Farid, he knows how much time he's spent sending mails, thinking, have you looked at this? Have you tried that? Popping up at 11 o'clock, but here's something we might have tried. I couldn't do the work I do in Spain without him. So thank you to those three. Thank you to all of you, but especially thank you to everybody who's been here for this event. Your presence, and I hope your sharing of what you've learned, is going to make that little fork in the road a little bit easier for everybody. So thanks. We're almost bang on time for 5 minutes past. Thank you very much. Have a good day. Keep safe. And now you know even more ways to keep safe. Try not to be too scared and sleep at nights. Goodbye, everybody. Goodbye.